Hello there, young students of chemistry. This is a quick recording regarding using significant figures when you are making calculations. So you've already learned that you can make a make a measurement with the proper number of significant figures. And when we're doing stuff with those measurements, we have to continue recording the number of significant digits that are present for our tool. So that's what we're going to talk about today. We're going to start by just quickly, can you determine how many significant digits are in a number? And then after that, we will move on. So here's the issue with significant figures. When I say figures, I'm talking about numbers. So there are rules about significant digits, and the rules go like this. All non-zero digits are considered significant. The second rule is that, so like that leaves us with just the zeros, right? So the second rule is that captive zeros are significant. So any zero that is in between two non-zero numbers will always be significant. The third rule is that leading zeros are never significant. So we have captive zeros are always significant, leading zeros are never significant. So what that leaves are trailing zeros. Trailing zeros are sometimes significant, and it really just depends on whether there's a decimal place present. Without a decimal, trailing zeros are insignificant. If there is a decimal place, then trailing zeros are significant. So those are the rules. I realize that some people are visual, so because of that I have this little system derived here. So I'm going to talk about the rules and this little graphic to help you do significant figures. We'll look at them both. So basically, I want you to understand that the Pacific Ocean is on this side of the continental United States. What we swim in is the Atlantic. And that Pacific and Atlantic really stands for present and absent. And that's talking about the decimal place. And it really just tells you which way are you going to look at the number. Are you going to go from left to right when counting, or are you going to go from right to left when counting, depending on whether the decimal is present or absent. So when you're counting, you start counting at the first non-zero digit, and then after that, you just continue counting in the direction that you started. So when we consider our examples here, the first example is 40.7. The decimal is present, so we're going to come over here. We start counting with the first non-zero digit, and that's a 4. That digit and everything to the right of that digit is significant. So this measurement has 3 significant figures. The rule here is captive zeros are significant. So every non-zero digit, the 4 and the 7, are significant, and because we have a captive zero, that is also significant. In letter B, 97.00 kilograms. That's a mass. And we can see the decimals present. So we're going to come from the Pacific, the left, start counting with the 9. That number and every number to the right of that is significant. So we have 4 significant figures in that number. Letter C. Okay, I'm sorry, and the rule there is that trailing zeros with a decimal place are significant. So it's really the trailing zeros that are the problem. Captive zeros are always significant. Leading zeros are never significant, but trailing zeros sometimes are significant, and if there's a decimal place, they will be significant. Here we have no decimal place on letter C. We're going to come from the Atlantic, start counting at the 6, and then travel from right to left. And we can see that there are 5 significant figures. The rule here is that captive zeros are significant. So what we have here are 2 captive zeros between the 2 and the 6. Letter D, we have some trailing zeros. And remember that trailing zeros are sometimes significant. So we have a decimal is present. So we're going to come from the Pacific, start counting with the 1. That's the first non-zero digit. And then we're going to proceed to the right and counting all of those digits as significant. So we have 6 significant figures in this number. Letter E is the same value in magnitude, 1200, 1200, However, our tool is different, and we know that because there's no decimal place. So if we're coming from with the decimal being absent, we're going to come from the Atlantic. We don't start counting until we get to the first non-zero digit, and that's the 2. That number and everything to the left of it is significant. So this value has 2 significant digits. Remember that this value of volume, centimeters cubed in D, that measurement was made with a tool that has a mark for every 1/10 of a milliliter or centimeter cubed. Letter E, that measurement that tool has a mark for every 1,000 milliliters. Remember, the last digit is always estimated, and then the digit directly to the left of that is the known. So here we have our estimated digit, and the 2 here is our estimated digit. If we'd put a decimal on that number, it would have told us that the ones place was estimated. So just kind of tying that into what you learned about using the proper number of decimal places in measurements, so significant figures when you're making measurements. Okay, letter F, the decimal is present, so we're going to come from the Pacific. We start counting with the 5. That and everything to the right is significant, so that has 3 significant digits. The rule here is that leading zeros are never significant. Letter G, we have some trailing zeros and no decimal place, so we're going to come from the absent. The decimal is absent. We're going to start counting at the 4, so this has 2 significant digits. And then letter H, the decimal is present, so we come from the Pacific and start counting with the 2. That has 1 significant digit. So back to the rules. Letter F, leading zeros are insignificant. Letter G, trailing zeros are insignificant if there's no decimal place. Letter H, leading zeros are insignificant. Letter I, trailing zeros are significant if there is a decimal place. So letter I has 4 significant digits. The decimal is present. We come from the Pacific, start counting at the 4. That 4 and all of the zeros to the right of it are significant. So I'd like you to pause the recording and take a minute to do the you try it's on the back of your notes. Okay, so take a minute to check your work. We have used the rules or the Pacific Atlantic method for determining significant digits, the number of significant digits that are in a number. So the next thing you're going to have to be able to do is take a number that your calculator spits out and round it to a particular number of significant digits. Now that's hard because sometimes students think that sometimes students will change the magnitude of a number. So the number that we're looking at right here is 50,600. You guys, we cannot change that. That is 50,000. We can't turn that into a 5. So when you're rounding with significant digits, before the decimal place, we just turn non-zero digits into zeros. So if we want 1 decimal place, we start with the 5 in the 50,000. I'm sorry, 1 significant figure. I said decimal place. Please forgive me. We start with the 5. And then everything after that becomes a 0, so 50,000. We're not going to include a decimal place because in doing so, that's going to make those zeros significant. And that would be that trailing zeros are now significant. If we want 2 significant digits, we're going to keep the 5 for the 50,000, and then we're going to keep the 0 for the 50,000. However, directly to the right of the 0 is a 6. Anything that 5 or greater, and we're going to round that digit up. So this becomes 51,000 milliliters. And remember that we should leave the decimal place off. If we add a decimal place to that, we're now making those zeros significant, and we don't want to do that. To 3 significant digits, keep the 5, keep the 0, keep the 6, and keep 2 zeros, 50,600. To 4 significant digits, we have 50600. Now listen, that does not have 4 significant digits. With the decimal absent, we start counting at the 6, and that has 3 significant digits. So let's try plunking a decimal place on that. 50,600 decimal. By doing that, the decimal's present, and now we have 5 significant digits. So when you cannot get the number into the proper number of significant figures, just by rounding, then you have to consider using scientific notation. As a matter of fact, the only way to get this number expressed to 4 significant figures is to use scientific notation. Now, you learned about scientific notation in 5th grade and in 8th grade and then also in math classes, so I'm not going to go over that with you. But if you need refreshers on that, you should read your book or come see me after class. So we have 5060. Remember, in scientific notation, there's 1 digit to the left of the decimal, and then that's going to give us the significant figures. And now we determine the magnitude of the number by multiplying that by an exponent. We need 50,000, so we need to move our decimal 1, 2, 3, 4 places to get to 50,000. I'm going to come up here and go 1, 2, 3, 4. And then, of course, we'd have our unit, milliliters. Now, once we get past the decimal place, all we start doing is dropping numbers off the end and rounding where we need to. So these are a little bit easier. 5 significant digits is going to be 50,600.1. 1, 2, 3, that's wrong. Decimal, just the decimal place. So we put that decimal place on there telling us that we need those significant figures, those zeros at the end, to be significant. To 6 significant digits, 50,600.1. To 7 significant digits, 50,600.07. That rounds up. By the way, these are all milliliters. I'm getting a little sloppy here. And then to 8 significant digits, 50,600.068 milliliters. Okay, so that is how to determine the number of significant digits that are in a measurement, and also how to round a number using significant digits. The next recording is going to be how to use significant figures when we're using mathematical applications.